We have this question here, 3.2, that says 6 minus x, 5, and square root of 4x plus 12 are the first three terms of an arithmetic sequence. The question says determine the value of x. Okay. What we need to know is that an arithmetic sequence has, okay, let me first write the question. So we have like 3.2. We have like 6. So the question is to determine 6.2.1. So we're looking for x in this question. Okay, this is the unknown. We need to find x. So it's x that we're looking for. Now it says determine the value of x. So we can see from the question that we have given an arithmetic sequence, okay? Arithmetic sequence has one condition, or it's bound to the definition of an arithmetic sequence. The first difference is constant, okay? So it has a constant difference. So what does it say? It says like T2 minus T1, okay, will be T equal to T3 minus T2, and so on and so forth. So all this equal to D. The constant, there's a constant difference. So here I'm going to say there's a constant difference. Constant difference. Now we will look at the terms as they are. There are 6. The first term is 6 minus x, and the second term is 5. And square root of 4x plus 12, etc. Now it means that the difference between these two terms, will be the same, will be equal. Whatever we get here will be the same as whatever we get there. So the difference will be constant. Now let's work it out. It simply implies that therefore 5 T2, because this is like this is like T1, that is like T2, and that's T3. So it's like 5 minus minus 6 minus x, okay, will be equal to square root of 4x plus 12 minus 5, okay, because the sequence or the sequence are arithmetic sequence. So this implies that we have like 5 minus 6 plus x equal to square root of 4x plus 12 minus 5. This is like x minus 1 equal to square root of 4x plus 12 minus 5. Now, to simplify this, we can move the negative 5 over. So this will be like x minus 1 plus 5 will be equal to the square root of 4x plus 12. Okay, this is x plus 4 equal the square root of 4x plus 12. Now, to simplify this, what I can do is just make sure we line here. We will do x plus 4 square root of 4x plus 12. We can raise this, okay? So it's like to find x, we can raise both sides to the power of 2, okay? Why to the power of 2? Because I need to simplify, I need to get rid of the square root. Okay, I'll raise it to the power of 2. Then this will be like x plus 4. Yes. X plus 4 in bracket like that. To the power of 2. And then the power of 2 here will cancel the square roots. And then there will be 4x plus 12. Okay, so I prefer to write this way. This will be x plus 4 times x plus 4, and then this will be 4x plus 12. Now we can expand x times x as we do, like x times x times 4, and 4 times x, 4 times 4. And this will be like x squared plus 4x plus 4x plus 16. This is equal to 4x plus 12. Now we can move whatever we have on the right hand side. All this, we move it over here, and that would be x squared plus 4x plus 16 minus 4x, and then plus 12 equal to 0. Then we can combine like terms, okay? I prefer to underline. Look, we have x squared here. Is there any number, any term in terms of x squared? No, there is none, x squared. And then I can look here, 4x, and negative 4, and negative 4x. They all expressed in terms of 4x. I can just cancel this and that, and then this will be 4x. Now, I have left with 16 plus 12. Oops, it won't be 16 plus 12, but 16 minus 12 now, because positive 12 moved over becomes negative 12. That makes 16 minus 12, which is equal to 4, equal to 0. Now, to find the value of x here, we have a quadratic equation here. We can factorize, or we can use the quadratic formula, or we can complete the square roots. I prefer to factorize here. So this will be right x, close bracket, open bracket, x, close bracket equal to 0. Now, to factorize that, I'm going to look at the last term, okay, which is negative 4. But now, let's just take 4. Okay, I know it's negative 4, but we will list all the factors of 4, okay? In ascending order, preferably, they are like 1 and 4, and 2 and 2. Now, we ask ourselves this question: how can we get a sum which is equal to the coefficient of the middle term? The middle term, which is positive 4. Now, let's see. With 1 and 4, we cannot make a sum which is equal to positive 4. But with 2 and 2, yes, we can. Oh, excuse me. Here it was positive 4. So positive 4. Yes, with 2 and 2, yes, we can make a sum equal to positive 4. And of course, 2 times 2 makes positive 4. Then over here, we can just place in plus 2 and plus 2 there. Obviously, because this is common, we can just work out 1, x plus 2 equal to 2 equal to 0, which means that x equal to negative 2. So that the value of x that will make this sequence over here an arithmetic sequence. Thank you.